before that, I would request, we have our two vice presidents. I would request Mr. Tilochan Mohantan, please come to the dais. I would now request Mr. Ramanath Praharaj to please join the dais. And today's speaker, Mr. Piyush Srivastava, former Chief NRT Tata Steel. I would request him to kindly raise the dais. Now I request Mr. Tilochan Mohantan to start the program. Now the bouquet is being presented to our speaker, Sri Piyush Srivastava. Thank you. Sri Mohantan sir, please.
Thank you, Mr. Das. For the benefit of the speaker as well as members, though everybody is aware of it, I will just speak a few words about SGT. As you all know, this organization, a non-profit making organization, it was started way back in 1980 by a handful of geoscientists belonging to the State Directorate of Geology and State Unit of Geological Survey of India, Odisha Mining Corporation, and only a few other organizations of Bhubaneswar. Many stalwarts were there at the beginning, like our former patron, say Vijay Krishna Mohanty, the former Director of Mining and Geology, Professor Satyananda Acharya, Professor N.K. Mahari. From mining side, Mr. K.C. Pradhan, Mr. R.L. Mohanty, all these people were there when this was started in 1980. Actually, the concept came when some persons were there in Utkal University as teacher fellows. And I remember how they were regularly going to Puri with their Lambretta scooter to get this organization registered as per the society's registration. Anyway, after that, this institution has gone a long way. By now, we are having 930 members from Odisha, outside Odisha, many states of India, and also some members from abroad also. The regular activities that SGT does. It conducts workshops, conducts seminars, and apart from that, it has been conducting two programs. One for the school children, which is held every year in 12 mining and industrial regions of the state. And the winner teams are again brought to Bhubaneswar for the state level environment cum mineral awareness program. And another one is the Mineral Development Awareness Program for the postgraduate students of Earth Science and the BTech students of mining, engineering, metallurgical materials, and mineral engineering. These are two unique programs which are not being done by any other organization in the state. We have just scheduled the next MDAP program for the August 20 to 23rd of 2026, for which the process has already started. During COVID, actually, when congregation of people or meetings, etc., were not possible, we started two programs. One is the Distinguished Lecture Series, in which distinguished persons from across the globe were invited to deliver talks on the topics of their interest, and this was always made online. So in this connection, people from United States of America, United Kingdom, from Ethiopia, many people they have talked. We have nearly completed in DLS 11, I think we have completed. And another parallel program was this fraternity presentation program. And this program, here the outsiders were not invited, rather the members of SGT, they were invited to give talks on topics of their interest. In this regard, the first fraternity presentation program was started on 28th of September 2022, and Professor Bhavesh Sarkar of IIT ISM Dhanbad, Department of Applied Geology, he was the first speaker in this fraternity presentation program. And the seventh, which has already been completed, fraternity presentation program, was conducted on 13th January 2026, and the speaker is here sitting in front of us, Professor Emil Goda. So, in this connection, today is the 8th fraternity presentation program, which will be delivered by Mr. Piyush Srivastava. So, we hope it will be an interesting talk for everybody present here physically and also those who have attended it online. So, Mr. Chambers.
Before we start the lecture, I think it is a privilege that we know our very distinguished speaker who has more than 37 years of experience in one of the biggest the public sector, the private sector organization, that is Tata Steel, where he finally retired in 2025 as a head natural resource division. and he did his BTech in mining way back in 1988 from BHU. And after passing to a mining engineer, he, as a graduate engineer, joined in the Tata Steel. And in the process, during his journey in the Tata Steel, he did MBA Finance from XLRI 2002. And the best part is he is a certified black belt in Six Sigma and the theory of constant at the TOC application expert. These two that says quite high about him, and it also says that he is an expert in top management, and he has that capability who can do the management analysis such a way that the management gets the maximum benefit both in the finance as well as the quality of the work. And Mr. Srivastava also had done the certification program of independent director from IIM Bangalore in 2025, and is a certified independent director from Indian Institute of Corporate Affairs under Ministry of Corporate Affairs. So as I said, he has 37 years of glorious experience, and he has worked in different aspects of the mining, that is mining operation, mine planning, land acquisition, mining projects, greenfield projects, and improvement initiatives across mining locations, covering both open cast mining and underground mining. In his role as the chief of NRD, he has taken initiative to start geotechnical cell, hydrological cell, drone-based digital mine monitoring, and geoinformatics to make NRD as a complete solution provider for mine exploration, mine design and scheduling, geotechnical investigation, mining projects, techno-economic evaluation, preparation of statutory mine plan, and other value-added service like mineral resource evaluation, feasibility studies, MDO contract selection, etc. Due to his leadership, Tata Steel is now monitoring its mines through drone-based survey and mine analytics using multiple software through cloud-based platform. As a change management initiative, the NRD Tata Steel is gearing itself to provide world-class mine technical services to clients in India and abroad on commercial basis and convert the 100-year-old division from cost center to profit center. And that's a great achievement for Piyush Srivastava. As a chief land RM, he has been in the forefront for implementing georeferencing of land, creation of linked database, and mapping of land using DGPS survey and ArcGIS across various mining locations. That is quite informed about the latest technology. Mr. Srivastava has expertise in areas like mine planning, mine financial modeling, mine statutory clearance, GIS mapping, and project management. The Srivastava is a member of various professional bodies in mining and has written number of technical papers in leading Indian mining journals and seminars. So this is the Piyush Srivastava who is in front of us. I would request Mr. Srivastava to start his presentation. Please.
Thank you. I will sit down and make the presentation because I think my laptop is also transferring. So I'm not the only person to speak. Besides me, there is a team from NRD, and they will show you some practical aspects how drone is being used, how other technologies are being used for increasing productivity and safety. So let me just confirm. Indranil, can you hear me?
Whatever. Like.
Indranil, can you hear me? Can you hear me? Can you hear me? Okay, thanks, sir.
Am I audible, sir?
Yeah, we can hear you, but I think.
Yes.
maybe-
Online, it's coming clear online, yes.
Okay. So, what I want to present is the initiatives that we have taken since 2009, when I actually came to Bhubaneswar as chief of Tata Steel. That's the time when I was able to work with an international team, mainly from South Africa, US, and of course, various companies of Tata Steel, including Tata Protects, Tata Sons, Tata Limited, Tata India. In that team, we did not follow the normal processes, and we followed some of the international practices. The first DGPS survey, which was done in Odisha, was actually done by us. And the guidelines for DGPS survey, when they were written, I think my team had a good role. So today, what I'll describe is the technologies, which will solve our goals and our DGPS latest more, inclined towards the mining sector. Not so much on exploration and geology, but I'm trying to cover that as well, especially that's exploration. Next slide. What I want to cover is what is digitalization, limits of digitalization, exploration, mine planning, in the equipment availability, was mining cost, major cost is the equipment cost, the equipment maintenance cost, then about the safety, open cast mines of ground control, and also underground it's about the safety of roof, and then about the monitoring. They are not just the regulators, the mine management, they want mines on a live basis. So we'll cover some of those technologies. Also, the data which comes from IoT devices, various sensors, the data needs to integrate. So there is a control room. You imagine a scenario, there's a control room. Data comes
Location
cost, dispatch, quality, that data is trained. I don't know how many mines are there. Tata Steel has really did this kind of dashboards where in one place all the mines. So, as of now, I don't think there is any other way, neither.
gaming laptop.
Hopefully, I think maybe Aditya Birla Group, I think they're working on this. Vedanta is working on this, and in times to come, they will also have this kind of integrated, digital. Next slide. So when I say digitalization, next slide. There's a difference between digitalization and digitalization. So digitalization is more about using the digital technologies. And when I say digital, it means using the data to make decision making. If we digitize everything but we don't use the data, then digitalization is incomplete. So when I say data, it is the data, not the analog data, the analog data which is converted into digital. And therefore, there is a plethora of information which comes digital. So it comes from equipment, it comes from the safety devices which the people are wearing, it comes from the dispatches, it comes from quality. The spatial data which is a drone-based data is a very data. Therefore, you will find that data restores on the cloud. Such huge data cannot be put into laptops. So data is in the cloud, data is in the servers, and then from various sources when the data comes in, you get those integrated reports. Now this integration is a key. I'll cover this later on. But the key thing is, when I say digitization, it means using data, and data is a good data. It comes directly to the source. If the data is coming through Excel sheet or through written notes or through paper, then it is not a good data. So data which can be captured from the source automatically using various tools, special IoT devices, or even input. Sometimes input needs to be given. All the input in a digital format. Then you can assimilate the data. You can integrate the data and create various dashboards. So we'll come to those dashboards also. Next slide. So we'll talk about in mining context. We'll talk about the geological data that we use through the resource modeling in exploration. And exploration has become quite high tech. India is very short of exploration, so we cover that part of it. I'm not going to cover much the equipment side, but the equipment side is the health of equipment. For example, the mine that say 10 million ton mine, open cast, say coal mine with a stripping ratio of 1:3. The cost may the capex may be something like 2,500 crores. Out of this 2,500 crores, around 10%, 50 crores will land R&R. The major cost is the cost of equipment and maintenance of those equipment. So we want our equipment to be utilized fully. The availability should be very high. So application of these digital means to improve the equipment of the mill, to improve their availability and utilization is something very, very important to any mechanism. We'll talk about compliance. Compliance, not just what we give IBM into Ministry of Coal, but compliance in terms of the management. Management wants to see your plan, your mine development is as per the plan. You are giving the quality of the ore produced as per the plan. What are inventories? You would like to see the inventories. Okay, so those things can be online, can be digitized, and the planning, which to my mind, to digitize everything. If the planning is done conventionally, then it is not a mine. So I'll come to it that my planning and geological modeling becomes the fundamental base for digitalization because that helps in development of the mine. And we'll also talk about the safety where slope stability, the SSR, other SR and such technologies are being used for safety and quality. Next slide. So digitalization is why digitalization? Because we want to improve the decision making. The main purpose is improve the decision making. Now imagine a scenario where for every decision we have to go to the manager, take his permission. If the data is online, if the people are empowered, if they get the analysis, and then they take the decision right at the place where the action is happening, then it's so when I say digitalization, is also the same problem. People in the front line are taking decisions, which means will take timely decision and correct decision, productivity will improve, safety will improve, and of course efficiency. Okay, so the bottom line is it is an ecosystem of mine data, plans, operation submit the completion for a proactive planning. So the key is proactive planning led mine development. Next thing. So we'll talk about the digitalizations. First is there is a mind that wants to start the digital journey. The first step is to assess where are they in terms of data capture. The first and primary thing is the data capture. Sometimes data is being captured manually. If the data is manually captured, then of course that's the first place where you start. Then the next layer is the digitization. The data is coming, is it put into a format where it is digital, it can be assimilated, it can be integrated. That comes the next. Third is the planning part, where we insist that your geological data should be a resource model, 3D model should be there. Your planning should be through certain software which can not only tell you what is the current situation of the mine, but also the situation of the mine which will happen, which will come in next 2 months, 3 months, 1 year. So that kind of prediction can also be seen both in 3D and 2D. Then there is a real-time visibility of the mine. Now, today we have tools where if you go into the mine and see the mine, you may not understand so much. But sitting here right now, I'm Tata Steel will show you how sitting in one room, they can actually visit the entire mine. They can see, look at corner of the mine. They can travel through the mine. And today there are technologies, if we have a VR, then you're going down the road, then you will feel as if you're actually going down the road. So, those VR is not necessary. The point is, through digital methods, drones and scanners, you can actually visualize the mine in 3D and you can see every little corner in a shorter time, in a safer time, while sitting in the comfort of the office. So that real-time visibility is there. For mine safety, geotechnical data is very important. Not just geotechnical, also hydrogeological data. And in my experience, what I've seen people, they use the empirical formulas for geotechnical and hydrogeological. Whereas numerical modeling is something which is very, very popular. It gives you much better understanding of the distribution of stresses, distribution of the factor of safety, those things. So, geotechnical digitalization is extremely important. Then you have done the mining as per plan and you dispatch the quality, dispatch the ore to the customer. So where is the ore? How is it going? What is the quality of the customer and what is the quality of ore at lower end? So this entire, mine to mill that we call, how is it being done? So this NTPC faces a big problem. The quality of the mine is recorded something else. The quality which is received with power plant is something else. So this mine to mill, there is no integration. Okay. So how do we do that? Then the advanced layer is the AI layer. Now today the data is so much, it's in hundreds of GBs. So much of data is there. How do you make sense from the data? So making sense from the data, sometimes, for example, in the hyperspectral survey, multispectral survey, where various layers are there, and there are mineral signatures are there, how to make sense? People have been doing it manually, but today AI plays a big role in such things. AI also plays a big role, even in mine analytics, in terms of, we'll come to drones. The drone data that we get, how do we understand the all road gradient? How do we understand the slopes? There again, the AI plays a big role to understand the safety of the mine. So implementation strategy, the one and the foremost thing is digitization doesn't happen from CapEx. You may spend money, you may do anything. The key is the people and the change management. And I have faced it. It's not easy to convince the operator. It is also not easy to convince the MD. Okay. And there's a huge resistance. MD may not see the benefit of it because he doesn't know about it. The operator will resist because any change is resisted. So surveyor may think I will lose my job if the drone comes. So this change management is key, and for change management, training the people, upskilling them, it is the key. Without upskilling, we cannot reduce digitalization. So This is one of the key takeaways. Next slide. Yeah, so basic components. Next time. Yeah. So both open cast and underground, certain things are common. So there is a planning is done for underground, planning is done for the open cast using the various mine design scheduling software. The geological modeling, whether it's open cast, underground, there's a resource modeling, it's always there for both of them. The drone survey is easier in the open cast because it is optical means we do optical camera. But today underground drone survey is also being done. They use the laser camera. So if you go to Hindustan Zinc in Rajasthan, they use the stopes, they put the drone inside. So they can see everything, the screen what is created. And because there's plethora of data, the AI analytics is a necessary layer. Visualization can be done in the open cast and underground. Underground is not easy because GPS doesn't run. So underground visualization happens through the IoT devices where and the video cameras where underground what is happening underground can be seen on the surface. So whether it's quote unquote the LHDs or whether it's Sgat conveyor or it is the long wall phase, everything can be seen. The field is given to the surface. There are some mines now which are also operating remotely. There are 1 or 2 people underground for maintenance part, but the mine is being operated remotely. So that's the major difference between open cast and underground in terms of the communication. It's more difficult with communication underground. The acquisition there is same. You require IoT devices, sensors, camera, those kind of things. And there is a communication network. In open cast, we have Wi-Fi, we have 5G. So communication is quite easy. But underground, we have certain radio signals from which we communicate. And the data platform, once the data comes, we need a server, we need a certain a cloud platform to which the integration can be done. Next slide. So open cast mine, I think I've covered all this. You can do digitalization for the geological, for the fleet management system. Open cast mines means the heavy equipment, dumpers, shovels, dozers, haul dumps. So those equipments, they are monitored, the performance is monitored, utilization, and also the data which is about the efficiency improvement. For example, for numbers, what is the consumption of diesel? It's very important data. It can be monitored also. Drilling, blasting, it's very data driven. The production and dispatch in terms of inventories, what is online, what is on the way, what is at the customer end, all that can be digitized. And of course, the geotechnical data, no more we can afford to be only using the empirical formulas. We need to use more data-driven approach. And of course, mine to mill means from your end to the customer end, where is the board, how is it being dispatched, and how are the inventories. Next thing. So underground mine, I think important is the communication. We call it leaky feeder, which is basically emits the radio waves. When those radio waves communication happens. There are fiber optic cables and various sensors, for example, load sensors, the camera feed. It is taken through an optic fiber cable or even the leak signals. So underground, especially if it's an underground coal mine, there are additional costs taken because of the inflammability of the gas. Environmental monitoring in underground becomes very important because of dust and also gas problem. The digital mine development and planning, of course, 3D stone, in open cast, you can like drone underground or so flying the drones in underground is a very specialized area. Other than Hindustan thing, I don't think any other mine is doing it. And people become very important because they are working in a area which is prone with prone to safety. Unsafe things can happen. Therefore, the safety of the personnel and gadgets which people wear underground becomes very important. So ventilation is another area. So a lot of devices are there to tell us about the flow of air, about the temperature, about the wet temperature, dry temperature, or the gas quantity, all those things. Next slide. Next slide. So, so digital, when I say, and I always think digital means you are taking the decision as per the data. If you have invested everything and the decision is again being taken at the top, it is not a digital file. The decision is taken on monthly meetings, it is not a digital file. Decisions are taken on a weekly meetings, it is not a digital file. Digital means decisions are continuous. As the mind runs, people take the decision. That is a digital. Next. So we'll cover exploration next. So exploration is when you do the exploration, one is the geological mapping. So imagine a geologist is there, he goes to the field on his iPad or a tab. He has the map of the mine. He knows where he is standing. And if he wants to know what is the quality of ore there, at that point, he can open the resource model, give his coordinate, he will understand what is the quality of ore there. He can see the sections. So there is something which he can see on the ground, but there is something which can get analyzed through the tab. So he may decide to shift the borehole position based on certain things which is there on the ground. But the data which is there on this tab, through which he can place the position of the machines functioning. Even same for the quality control system. Again, because he has so much of information on his tab, which can utilize while seeing things on the ground. Even he will have the data of the overall log of the nearby area. So he will understand in this place what is expected. So many decisions are taken because he already has so much information in stock, and he can see that information based on the current position. Next. So other is the GIS there. When I was talking about tab, I was saying that there are various layers. There's a geological layer, there's a surface layer, there is a mining layer, there's a quality layer, and these are all georeference. So we can compare those like basis and understand whether it is drilling, whether it is mapping, whether it's quality, by looking at the various aspects. And at least in Tata Steel, I think all the field geologists, they have a tab. They have the resource model of the mine, they have the quality map of the mine, and they can see the quality. And iron ore, for example, the quality varies from place to place. So where you're going to mine, it is not just the borehole data which gives you the borehole cuttings through which you can analyze what is the quality of the alumina, but through the geological model also you can predict. So therefore, this GI system, because different layers superimposing, taking out one layer, seeing the other layer, all this can be done automatically. Next. So remote sensing, and this is about using satellite imagery, whether it is multispectral, hyperspectral, various signatures, every mineral, every rock has a signature, vegetation has a signature. So all those signatures can be mapped And today drones are used in a big way, not for multispectral but for hyperspectral. This is a very intense data using from hundreds of times. So you can see the data in a very close level. So for trace elements, for critical elements, they are not massive hardware bodies, they are limited. So you require very small signatures are there. How do you make those small signatures? So drilling you may not pick up. But through hyperspectral survey, those signatures can be picked up. And when I say hyperspectral survey, these kind of intense data, humanly it is not possible to make decisions. Sometimes there you require this AI tools to understand, make sense of the data. Next. So drone-based exploration is, of course, we can use radar, we can use thermal cameras because it's a mine which has got fire. Where is the fire? Where is the concentration of fire? So I took this thermal camera of the drone and find the drone, I get the signatures. Again, I then take that map and put it on the GIS. I can see the hotspots. I can put the surface plan and see where are those hotspots. Is it near the building, near the road? Is it near the magazine? So, so drones are playing a very, very important role. So same drone you get magnetometers for surveying, radar, thermal cameras, multispectral and hyperspectral. Next. So geophysical, I will not go into this, yes, but this is geophysical survey is becoming high tech. Gone are the days when you get the data, there is somebody who gets the data, he makes calculations, empirical decisions. No, today the data is being put into software and numerical modeling is being done to understand how those various parameters are distributed in a given field. Next. Yeah, same with geochemical. So, drill hole digitization and smart drilling is one is as you drill, there are cameras inside which can sort of scan the borehole surface, and logging can be done while drilling. There are very few companies in India who do it, but it can be done. So, log while you drill. There's a word for that, I'm forgetting the word. Then, of course, after you drill the hole, you put the data logger to again understand one thing. The code is there, scan the code. So, after maybe physical logging is also done, but you scan the code. So, permanent library can be done. If you go to Melbourne, Sydney, I saw a very beautiful code library there. And they have records last 20 years, 30 years. That kind of system, I think we in India don't have. But big companies, GSI, etc., they have to adopt even I do. Next. So I will not go to resource modeling. You all understand resource modeling is fundamental. What is inside the ground? What is the orientation of the core body? What is the quality of the core body? This comes from a very tedious process. We use Linux, we use Serpent, data mine, whatever software we use. But resource modeling is something which is important. It's not a one-time job. Resource model again has to be updated. A good frequency could be maintained, depending on the type of mine. Next. So when I said artificial intelligence and machine learning, what is AI? AI is nothing but whatever information is there, it is tokenized. What I speak, it is tokenized. But the speed at which it discovers the pattern is humongous. Okay. So because we are using so much of data, we have to use AI. There is no other way. Humanly, many things are not possible because we require speed. And also, when you have this kind of data, there's a lot of noise. Now, to get the real information and separate the noise is not so easy. Again, we require these kind of tools to separate the noise from the actual data. Next. So again, cloud computing, the data that you have has to be on the cloud. And big data is again a form of AI, where on a huge data you again perform the same. Next. The key is the data has to be centralized. That is next. Next.
Okay.
So I will not talk about digital twin, which is if you have that 3D model of the mind and if you have the surface layer, you can superimpose this and as if you're going inside the earth to see the ore body. You can see the structures, this faults, etc. You can see. If there are certain gold mines and there is some sill or some dikes there, that also you can see. Your current workings are there. You can actually see the 3D model, everything together. Maybe Tata Steel will show an example where they do this. Next. I'll skip this automation robotics, I think everybody understands. So integrated data, digital is what I was talking about, simply from the borehole data, from the logs to the drilling, and during drilling, how the drill behave. There is a lot of geotechnical data which comes through while do the drilling. That data, and of course, once you get the course, the analysis which is done, all that data needs to be put centrally. And when you do the geological modeling, if it is done in that kind of detail, a lot of what makes sense then you know. Next. So I will not go into data capture analytics. I think for the possibility of time, skip this next. Again, I'll skip this. It is again use of AI ground based. Next. So future trends, of course, resource modeling, use of multispectral, hyperspectral survey, geochemical survey. When we say exploration, it is mostly conventional we talk about, but these digital, maybe the current system that we have about exploration, the way the exploration licenses are being given, a lot needs to change because the exploration agencies, they are not using the tools. And I leave this question with you, why they are not using the modern tools? Is it too costly, or they are not getting paid for it, or the risk is not being covered? Next. Okay, next. So we come to the geological database. Next. Next. We have spoken block. Next. You all understand what is variograph and GIS integration. I have talked about this. Next. Another important part of mining is the land. Land acquisition is a very important part, and therefore digitization. And one story, when I went as chief of land in 2015, Tata Steel was purchasing a lot of land. 93% of the land we had to lose, either because of land dispute, ownership records are wrong, or some dispute in the land. We were never able to take the position of land. What we introduced was the GPS survey, drone survey, and mapping the land. So before we used to purchase the land, we would put the boundary and see what happens there. So I think last 15 years, a lot of companies have taken to this, but I can very proudly say that we were the first one to start using this way back in 2010, and then again went back to understanding the way. Next. Next. So pit optimization is again, before you do the mining, you want to understand what is the economic benefit. So there are software for that, looking at price, looking at the cost, looking at the various other risk factors. There are algorithms and software. One of the software is written, it uses optimization algorithms. Next slide. Underground mine, today, remote controlled LSDs, remote controlled drilling operations, 3D design of the stopes, development tracking, ventilation, automation for all those things is being done. Next. Next. Display this. So this is a video, old video. I'm sure Tata Steel will show you something. This is one of the mines. And this, what you're seeing in 3D here is actually done through a drone survey. And here you can see the actual position of the mine. It's a 3D. You can rotate the mine. Whatever is describing you, you can actually go and see the mine. And you can see what has been mined down and also what is below the ground. So what are the seams that need to mine future, that also you can see. So this kind of integration of the resource model with the drone survey, with the block model, all this can be done today and it's being done. You can analyze the slope. So just draw a line and you will get this slope. There is no survey required. On your laptop, seconds you can understand what is the slope of the dump, what is the slope of the benches. And not only that, you can actually digitize this. You can see plant versus actual. Okay. And when we do the scheduling, 3-monthly scheduling is being done to understand how the mine will move from point A to point B or time zone 1 to time zone 2. So this quarterly scheduling is done on a monthly basis. And that plan is being given to the shift in charge and to others. Next. So I will not talk about FMS, the fleet management system. As I said, in open cast mine, the biggest cost is the equipment cost. Okay, and we want to utilize those equipments. For example, 15-meter tube shovel, EX1200. The cost is almost, just the maintenance cost is rupees 30,000 per hour. And operating cost could be another 12,000 rupees per hour. Now, for 40,000 rupees per hour, if it is not utilized for say 6 hours, 7 hours, who's losing the money? So, and these are equipments which can work continuously, except it is the shutdown or breakdown. It can keep on working. So, there is a data which comes from the equipment. There is a GPS tracker, but there is also a lot of data which is coming from the machine itself. Caterpillar has a system to which star system to which you can understand the fuel consumption, you can understand the tire pressure, you can understand the there is some red signal warning is there on ground. The gradient, what is the for different lengths of the road, what is the fuel consumption that can come. So FMS is a must. Any open cast mine without FMS, I think they are going to lose money. So the SSR, the slope stability radar, these are of 2 types, but basically it scans. When it scans, it gets the coordinates, and the rate of change of coordinates tells you whether the mine is safe or not. So through the scan, there are software which will tell you the hot zones. It means these places from the previous time there is a deformation or there is some change in the coordinates, and therefore you need to pay attention there. So this will help us to, we see a lot of red zones repeatedly, we should move the equipment and persons from there. Archaeological study can be done, and there are again software for that. Next. So this is you're seeing a control room. I think Jamshedpur we have control rooms for all the mines. There are control rooms of not just mines. There are control rooms for the pellet plant. There are steel plant itself. There are control rooms now. So the operations are being done from the one central place. So dark factory, you heard the name. So there is nobody inside the plant. The data is coming online and people are controlling from the plant. So washery typically can be a dark factory. Everything is controlled in the control. Next. Yeah. So XRF, ICP, these are for grade control. You get the data. Again, it's a digital data. You can process. Next. Digital twin is nothing but in the control room, you see the mine, you can go around the mine, you can see the pressure, you can see the all roads. So this, as if you're traveling through the mine. Next. Next. So this is one of the manganese mines where same road survey and analytics is being done. What you're seeing here is the before after. Okay. So that is being done. I'm sure Tata Steel has. I have this one or two old videos, but this is one of the manganese mines. You can see what is the movement of the mine. You can find the dumping areas, the change reduction which happens from the previous time to the current previous month, current month, previous week, current week. Different profiles. You can just draw a line with the section. So you will understand from the previous month to this month what are the areas where exploration has been done. You want to understand the dump profile. There is no need to measure. Just go to the dump, draw a line, you get the profile of the dump. And also you understand what has been the profile of the previous month and the current month. So the change which happens in the mind, whether it is dip or down, that can be seen physically and also can be measured. All road gradient analysis. The width analysis, something which Tata Steel team has done recently is the bump which is there. There was one accident where the dozer fell from one bench to the next bench because the bump was not proper. So now they have made they do the drone survey. I think they will cover it. The volume can be measured directly. It takes seconds now. It's much more safe to measure the volumes. So now the drone flies. It does the certain algorithms. It is able to measure the bumps, and wherever the bump is not enough, it tells you precisely so and so place the bump is not enough. So the mine foreman is being told about it and he performs it. Next. So I said this amount of data has to be on the cloud, integrate data, and you need business intelligence. You need a specialist who can integrate the data. IT people are required to integrate the data, and this integration is not easy. When you do this, you'll find a lot of risks coming from management itself. Okay, so I feel that Volta will have a lot of difficulty with these kind of things because there are sometimes divergent interests. Only a very strong management, very strong leader to be able to do this. This is my actual experience which I'm doing. Next. So I think I will give time to Tata Steel because it's already 6:30. The slides have been shared. I think in future what I have told is let's go to the next one. So simulation and scenario analysis is very important. When I say this simulation, the economics of the mine are very important. Suppose you have to buy a mineral block. What is the valuation? So it is not just the cost per ton. There are many other things. So this financial modeling, risk analysis, scenario analysis is a very specialized area. And people bid sometimes, and you see so many blocks there, people bid for it, or they surrender it. The problem is this analysis. Next. So enterprise integration, the ERP data, the mine planning data, the geological data, the quality data, the dispatch data, all that needs to be integrated, and business intelligence has to be used where transparency is created. So when I say digitalization, one is data, use of data, other is transparency. So I miss that part. Digitalization creates a humongous kind of transparency. Only when the data is there, transparency is there, decision can be taken at the lowest level. Right decision will be taken at the lowest level. Next. Next. So I'm not going into details. So what are the future trends? Next. Next. So again, I'll skip because the achievements have a lot of data. You can view consumption, tire pressure, the if there is some heating happening at some place, if there is the equipment is at the wrong place, all that kind of data, various KPIs can be integrated in the dashboard, which is from where the control room can control all of this. Next. So Caterpillar, Hitachi, Komatsu, they all have their systems where it can be integrated with just log into a computer. All that information which you require can be done. Sometimes the analysis can be done. What is the problem can be solved in Google. You just have to log in to your laptop and they will analyze what is wrong with you. Next. 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 So I'm not going about emerging trends. So the next is few slides which will tell about what is going to happen in the future. Last slide. Last slide. Next. Next. Slide number 73. Yeah, so let me end here. Internet, are you there? Internet? Internet, are you there?
Sir, my audible, sir.
You're audible. You can share your.
Sir, presentation will do now. One minute. No, just a minute.
Let's stop for those.
Yes, visible.
Yeah, Internet. Yeah.
So I can start, sir.
Yeah.
Thank you, sir. Good evening, everybody. Thanks to SGET organizers for giving an opportunity to in front of all distinguished geoscientists and technologists. I'm Dr. Ibrahim Shah, looking after career Natural Resources Division in the Tata Steel Division. And my colleagues, Mr. Uruna Shaul and Surya Teja from Geospatial and Cell of Fraternity are also with me. I shall touch briefly on the not before going to the demo part. Purpose is that the right data should reach the right stakeholder at the right time, and so that we go to take the right decision and corrective actions. Problems actually that we face in the digital connectivity
visualization of the data, like the maps, images, in 3 dimension. Then localization of the data, say the data like PCs on the house. At least the sound is
Just a minute. Ask him to wait for a while.
okay.
I think there is a problem. You can't hear. Just 1 second. 1 second. But he's talking about a web-based 3D GIS platform. So all the geological data, all the planning data is stored as images across almost all the points. And centrally, everything is done. What is
এটা এই সংখ্যাটা কালি ହେଇଥିଲା করে it's almost extremely problem and civil kind of character. The audio of TLs are definitely. Cool. Okay.
Ask him to say.
what you are saying?
Sir, now I'm audible, sir.
You are audible, but why is very weak.
Now, sir. Is better or?
So actually, we are you're trying to interpret
স্পিকারটা লাগাবে স্পিকারটা লাগাবে
সেটা কত
সাউন্ডটা এটা নকলে ছেড়ে ইকো শুনুন
মাইক্রোফোনটা লাগাই দেবো সে মাইক্রোফোনটা নিয়ে আসো না
you are the speaker. Speaker that because
সেটা আছে बात कर दो ask him to say
I could listen to you, sir. I don't know whether.
now it is audible.
Okay. Start.
Okay, just,
yes
we are discussing about the problems that we face, the visual connectivity, the visualization of data, like the maps, images, localization of the data. That means this data like within the individual PCs or the laptops, and it is suitable is a challenge. When the storage, reaching the data to the operation team and placing the issues to the management for the review. So to resolve these problems, now we are using the Rainbow solution from Aero for visualizing the 3D orthographic images, DTM. DTM is the digital terrain model setup. And now the data are available. So this single window system, and this is a hierarchy based user management system, and the cloud storage and ensuring the maximum accessibility and the security. So this is on the data acquisition workflow. First, we select the area of interest. then GCP on the ground control ground planning. Then we do the DGPS and the survey, followed by pre-flight planning, road deployment and data acquisition, data quality assessment, and then the data processing for the various byte softwares. Now this slide is on the data processing workflow. Basically, there are one set of data. This is the raw data and the images and the GCPs. These raw data are taken to the cloud-based GIS platform, where the data is hosted, processed, visualized, and then the analysis is done. So the GIS software will do the data filtration, then QA process, create the DPM or the data model, and various type of minor analysis can be done, and send the data to the different stakeholders as per their requirements. Now, this is about the advantages of the role survey over the conventional method. The limitation of this and the conventional method, that is the total station. This is unsafe for the inaccessible areas, time consuming and labor intensive, but it gives a volumetric estimation range profile, but it is limited to operate only in the accessible areas. To address these problems, now we are surveying with the help of the drone survey. It is fast, safe, accurate. Multiple applications could be done and fulfill the statutory requirements. And the limitation is that this is a very large data set, big data, and the storage is a challenge. Now I'm handing over to my colleague, Mr. Piyush Srivastava, to show the demo part and different mining application regarding the drone survey data on the remote platform.
So good evening, a very good evening to everyone. So thank you, NNN sir, for giving us a brief overview of the drone survey process. So basically, we are showing you a cloud platform where we store all the drone survey data, because as sir was speaking, when you capture the data for even a 1 square kilometer of mine, it generates around 5 to 6 GB of raw data and around again 4 to 5 GB of output. So per month, sorry. Is my screen visible, sir?
Yeah. Yes, this one.
So this is basically that cloud platform where we store the data. So every Tata Steel, we do it on a monthly basis, a weekly basis, if on necessity with operations team. So and every month, at the end of every month, we generate around 300 to 400 GB data. So if you see over here, it comes around almost 4 to 5 TB of data we generate in an overall year. So storing the data on a local platform, local computers is a very impossible task, and it requires a lot of investment and all. So what we have done is we built a cloud and we have developed the software and tools to analyze this data within the cloud, so that every user will have an option to analyze and interact with the data at every location of Tata Steel. And this is a hierarchy based, and it is totally cyber secured platform. So the data, there is no possibility of data theft or anything from this side. So briefly, I will give you basically what the platform has the capability and what the platform can do. So I will start with one of our mines, iron ore mines. If you see, this is a complete lease of one of our mine, Nomundi mines. So this mine is around 12 square kilometer in area. You can see this is a entire 3D model of the mine. It is very highly accurate 3D model. It was having a resolution of 3 centimeter of resolution. So you can almost visualize what really it is happening in the mine. I mean, it's not a live data, but it's an actual live, not a live, but it's actual 3D model of the mine. So you can do the analysis, like you can measure what is my width of the road from here to here. It gives you the distance on the fingertips. you need not deploy your surveyors to go and measure the road width there. So it happens on a real time basis. You can do it directly. You can measure the area. What is the area here that you are having? So this all the analytics will be done on the platform. So you need not have a separate software for that, and it happens a lot. And if you see this has, you can see visualize the benches very clearly here what is happening here and all. So this is one of our iron ore mine, and the same is also one of our coal mine, that is West Pokhara mines. So this also the same thing you can see. If you can see, these are all the active mining areas where the mining is happening. I'll just show you in the 3D how the mining is. So you can monitor your drill cases, blasting cases, everything can be done on from the platform. And you can do the analysis where your toe and button spacing is right or not, or whether the benches are as per the height or everything can be measured from it. So one of the second most primary functions in the platform is you can do the pit profile analysis. Over the period of time, you can see how your mine has progressed over the time. You can see this one of iron ore mine. The pit has progressed in this. If you can see the blue profile, it is taken in 2022. And in the same profile is taken in 2026. You can see the difference in the profiles over the same area. So in 2022, the altitude at this point was 586. At the same in 2026, it has gone down to 527. So it's almost a 60-meter drop excavation has happened in this area. So it gives you the idea of how your benches are moving, how the benches has been done, profiled as per plan or not. So, and the third most primary be it volume of excavation, be it a volume of stockpiles. We can do it here itself on the platform. So I will give you a live example of how you can do it also. So if you want to measure the volume of the stockpile. So basically this is one of the stockpile at one of our mines. So I want to measure the volume of the stock here. So I will just draw a boundary of the stock.
Might you finish earlier?
Yes, sir. I concluded in 5 minutes. So we can see this is the volume of this stockpile. So and the next feature I will be demonstrating will be the swipe map. I mean change detection over the period of time of the entire this particular areas. So if you see, this is one of our iron ore mine. If you see where my pointer is, this is one of our western field. This is taken in 2022. The same data you see in 2026, you can see the how the mine has been progressed. This is one type of change detection analysis. The same in the particular mine in 2022, this dump has been we have planned in the same in 2026. You can see it has been completely made with this green patch. The same, if you see the safety point of view, you can see the haul road analytics. You can see it shows you where your haul road is as per compliance and where it is not as per compliance. It shows you the data also. What is the status of that particular patch? And so you can send your operations team to sort out that particular patch and make it safer. And same applies for this width also. So we can also see the width of the roads here. Whether it is red, green. The red indicates it is not as per. So these are the basic functionalities that our operations team use on a daily basis, which they find it very helpful and very insightful for them to have a more safer and productive environment. And that's all from my side. Over to Piyush.
Yeah, so
Sir, any questions, sir?
I have just opened the chat box. If anybody has any question, you can put in the chat box, or you can open your mic and ask the question.
Sir, any questions?
Audience, you can put on chat box, or you can open your speaker and ask the question. Yeah.
What are the sensors you are using it in the drone now? These are Sony's optical. So what are the advanced sensors you are using? What are the programs which is available? And how you are doing it in your cloud system or integrating the data and all? So it will help us in finding a program.
So when I say drone survey, drone is only 10% of the job. So drone has a camera, optical camera. It takes the pictures. Overlapping is 70% overlap. Front side, critical side overlap. And those number of pictures are taken, and those that is what they were showing you. These are integrated using certain ground control points. From that, you get 3D model, and you get the point cloud data. Now it is game of only software. So hardware is only the drone and the camera. That's it. Everything else is analysis.
These are all optical.
It's so drones. What we are showing photogrammetry is optical camera only. Okay, but when I spoke about the exploration, thermal survey, hyperspectral survey, the camera has to change.
Sensors are switched.
You have to put a different kind of camera.
Tata Steel is not having that sensor.
We are not doing it now. Thermal we have used. Thermal we have used for Vespocarov because there was a fire. But you see a hyperspectral camera is worth 7-8 crores. You require a much bigger drone. I was not able to convince my management to give me a hyperspectral camera. Okay, so these are a company which is into exploration, large scale exploration. They will invest in this. You can also put a magnetometer to the drone.
I don't know.
So, but whatever is that tool, whatever kind of camera, processing is the main thing. 80% job is processing the data. And that is there. So whatever we have shown you, the data comes, it is converted into a 3D model. There's a quantity of data. And from the quantity of data, you can make it 2D, you can make it 3D, you can import into ArcGIS 3D model, you can put it into a 2D, you can import it into a ArcGIS software, you can put it into AutoCAD, you can make the drawings, you can make the sections, you can import the quantity of data in the source model also. You can import the quantity of data into the mind design, the mind model. You get the latest profile of the mind. So it's a game of software. It's a game of skills. Tejas, for example, is an excellent. He's a young boy, maybe I don't know, 27, 28 years old. He has picked up. We need so many such kind of people.
Okay, thank you.
Any more questions from the audience, either physically present here or online? I'll request before you put your question, write down your name and organization where you are working.
Chat box open, you can ask the question, it will be
Answered.
answered.
So I think we should conclude, since there are no more questions. We will conclude, and I will request Mr. Kitish Patnaik to his present a vote of thanks.
So that's one second. So, just one last remark which I will say. Today, when I say digitalization, it is data. Data processing means use of multiple software and use of lot of AI. And then using certain matrices, the business intelligence to get dashboards. Instruments are there which give you the data, but data processing is the almost 80% of the game.
Okay, sir. Good evening, everybody present here. On behalf of Society of Geoscientists and Allied Technologies, I got the privilege to give vote of thanks. We are extremely happy that Mr. Piyush Srivastava has explained it very systematically on the fraternity lecture, what he has given in a very regular pattern and in a very elaborate manner. So everybody has got some of the important clues of digitization, then drone survey, and how they improvise the technologies by using different sensors. He has explained everything, every bit by bit in a mines, how it has been procured, all the data to a data bank, and how it can be utilized. So it is a very good experience as long as Society of Geoscientists and Allied Technologies. And this is the Fraternity lecture series number 8. And we are lucky that he is present and he has delivered a very good talk on the topic digital technologies to improve mine productivity and efficiency and safety. And besides him, his another partner is Indranil Saha from Energy Tata Jamshedpur. He has also explained some of the things in the lecture series very politely and very systematically. So I am also on behalf of Sgat. I give vote of thanks to Indranil Saha for his contribution, and we think that we are very happy that we got some sort of technologies, improved technologies and advanced technology in a platform like this. And those who are present on the online, I'm also very thankful to them for their presence, and I am sure that they will enlighten their knowledge in the geological field, in the mining field, and in environmental sector, as long as this topic is concerned. And I'm also thankful to the society members, those who are present physically here, directly interacting with our expert, Mr. Piyush Srivastava, regarding this topic. So we are very happy, extremely happy. So with this, I conclude my talk. Thank you.
Thanks.
I think with this, the presentation session comes to an end, and we profusely thank Mr. Srivastava for his effort. Thank you.